See, Mr. Judiciary, my fire says what?
You got this, eh? Are you fine with strength?
Yes, sir. Yeah, that's why I think.
I came here with a plan. I have a plan. I have my own plan. But it's because you're distracting it. People are still talking. Orientation is locked. Orientation is not locked, man. Oh. Come on, this phone. Let me unlock it then. I have business to manage. You don't have.
I can John. What do you want? I call him. What do you want? You got some drugs. How about you? I'm doing see the
Guys, don't forget everything you do this side, you are recorded, ne? The camera is this side, so everything that you do. Huh? Huh? Yeah, I'm trying to be an engineer.
But it's not for everyone, so.
I want to keep it this way.
Yeah, no, then you must sell it together. Maar dan must make. Huh? No, just sell it with. You want to keep. Still want to keep your phone at a fixed point. So now you sell it with. So now you sell leaves it and then it's gonna make something. You see? I think it's the same. Now you sell it.
Yeah, sort of tape it, this way.
I can leave it also.
I don't know if you'll be able to see for reference, ne? Yeah, I'll try to play in the middle. Alright, let's move. I'm gonna finish the song. I have a feeling that we are now very comfortable with stats, ne? And I'm happy that I hope even you, wherever you are, the quiet one who doesn't say that they are fine or not, you'll be able to answer this question. So we're just going to brush through these ones quickly. Same repetition. Cumulative frequency graph, one of the most important graphs. They can give you the frequency. You have to find the cumulative frequency. So the first one will be 15, then 15, plus 27 will give you the second one, 27 plus 43 will give you the third one, so on and so forth, until you get to the end. The value at the end is your total number of people who are involved. If you add those frequencies, it must still give you the same answer at the bottom. We also talked about lower quartile. Lower quartile is Q1. That's the keywords for this one. And then we have determine the cumulative frequency graph of learners who use their cell phones for more than 140 minutes. So they will always try to give you more than, so you can be able to subtract the two values. Ne? When you get there, please, you need to make sure when it comes to stats, we take everything. Ne? We leave no stones unturned. And then the second one, another way of asking this question, it can be two parts. It can be the one with the cumulative graph, and it can be the one that you have to start pressing the calculator. Just are the same. You need to know how to find the range, know how to find the mode of the data. The one that appears more or more frequent, the one that has the highest frequency is the one that is the modal data, or it can be called the modal class. It's a mode or a modal class. Modal class is when we have interval. Modal class when we have an interval. Know how to draw the Bosque and whisker diagram even when they give you the cumulative frequency graph. You need to also show it on that graph if they give it to you. And then one standard deviation, that's the one we talked about here this morning. They will also ask you about that one. And then once you are comfortable, then I think so far with the progress that we've made, I'm confident to say stats will be able to perform when it comes to stats. Right? The next one. Trigonometry. We're doing trigonometry. This is the most heartbreaking topic. It's heartbreaking how you perform it. Eh? So what I did is that I took out the parts that are showing you flags first, and I'll do the rest of trigonometry as we go. So I want you to be fine with this part that you normally skip, and then the first one. As soon as you see this, I don't know what happens to your head. Eh? All right. So you need to pay attention, or we're left with only 3 hours, and we only at the second topic, and we have 4. Okay. General solution. It will be given to you immediately after they tell you about identities, or they will incorporate it within the trig functions. Ne? So if you're given a problem like this one, we're going to use this question from the previous question papers to remind you on how you do general solution. Let's look at this problem. It looks like a straightforward question, but we have cos as a denominator, so I'm going to multiply everything by cos to remove that cos from the denominator. Are we okay? Yeah. So I'm going to have, let me just write to this side. Wow! Okay. Let me try black. Okay, we have 6 cos of x minus 5 equals to 4 over cos of x. I have a cos as a denominator, So I'm going to multiply everybody by cos of x. Multiply by cos of x. Multiply by cos of x. Are we fine? So I'm going to have a 6 cos square of x minus 5 cos of x, and on the other side I will have 4. Transpose this to the other side. I'll have 6 cos square of x minus 5 cos of x minus 4 equals to 0. Then this is now becoming something that we say it's quadratic. Do you see it? So we can use, let's see if we can factorize that on the side. We can also use the quadratic formula, but be careful when you use the quadratic formula. You must not use x, you must use cos of x. Né?
So, the integration of function must equal to 0. So, we solve the
the cos is not equal to 0. They're telling you that cos cannot be 0 because it's the denominator. They're saying specifically cos cannot be 0. Just cos. Yeah, cos not 0. The whole equation is equal to 0, not cos. Yeah? Okay, let me find the factors of 3. I have 3 cos of x, 2 cos of x. Let me see if it will work for me if I use 4 times 1. I multiply this, I get 3 cos of x, I multiply that, I get 8 cos of x, so I can see I can work out with this one. I need a negative, so this must be negative. So this must be negative, this must be positive. You can use that to factorize, and then I will have my 3 cos of x minus 4, and then 2 cos of x plus 1 equals to 0. And then you have 3 cos of x minus 4 being equals to 0, or 2 cos of x plus 1 being equals to 0. So you have 2 possible solutions. So let's start with the first one. And let's simplify this side. This will be cos of x. Transpose this to the other side, it will give me 4. And then divide by 3, it will give me 4 over 3. Capture. Cos of x. Transpose this to the other side, will give me negative 1. Then divide both sides by 2, and I'm going to get negative 2. So I have 2 solutions. I'm starting with the first one. The cos of x equals to 4 over 3. I'm going to find the reference angle. So my reference angle will be the second function of 4 over 3. And then my reference angle will give me how much? So no solution. Who can tell me why we don't have a solution?
So,
Yes. All right. The reason why we cannot get to, remember, if you press 4 over 3, how much do you get? It's what? 1,33. So if we are saying cos of x equals to 1,33, remember that the graph of cos of x can only get to 1. Maximum is 1 and negative 1. So this graph will never reach 1,133. Let's come to this one. I have cos of x being equal to negative 1 over 2. The reference angle nope. Yeah. So the reference angle is how much? 120. Is it fine?
Yes, sir.
Good. Now, I'm going to look for the last statement will be the one which is very important. Ne? The last statement will be the one which is very important. When we get to the reference angle, remember this is 120. Ne? When we get to the reference angle, this is a very key. When you look for the reference angle, please use the positive one. I'll tell you. And how much do we get? If we use the positive without the negative sign, is how much? 60. 60. Good. Let's use the positive one, right? And then we'll quadrants. Because once you get 120, it's already picked the quadrant for you, right? So you come back here. The last statement. Remember, you took this as a positive. The last statement say my cos must be. You look at the sign now. The sign is negative. Where is cos negative? Second quadrant. Let's start with this second quadrant, and then we are saying your x, which is the angle that we are looking for. If this angle was x minus 30, we will say x minus 30 right there. Are we fine? If this angle was 3x, we would have said 3x equals to. Are we okay? Hopefully we'll get problems like that. Ne? For this one, the good thing about this one, the angle is x. So remember, the second quadrant is determined by 180 minus the reference angle, because we said in the second quadrant we have 180 minus theta. In the fourth quadrant, in the third quadrant is 180 plus theta, and this one is negative theta. For us to define the second 180 minus the reference angle, the reason why I'm using a negative is because I want all my angles to actually, it is the acute angles. Fine. Then, not forgetting the period of cos. The period of cos is 360. Ne? So I'm going to say 360 k dot k is an element of all integers. If there is no k is an element of all integers, you are losing the whole mass. That's what you lost in the assignment. Wait, guys. All right. Okay. The reason why I'm using 180 minus reference angle. Pay attention. Can't ask a question and not pay attention. 180 minus the reference angle is because we know that cos is negative in the second quadrant. And the second quadrant is determined by 180 minus theta. So instead of using 180 minus theta, our theta now is our reference angle. So this is telling us that we are in the second quadrant. 360 is the period of cos and sine. Every time there's a cos or a sine, we use 360. When we have a tan, we'll use 180. But when you write it, you must write it 360k, k being an element of all integers. You must write that down. And I want somebody to reduce the integer 27. It's too hot. Remote people, or switch it off. So far. All right. And then you substitute and say x will be equal to 180 minus the reference angle. Our reference angle was actually 60. Then plus 360 k being an element of all integers. So our x value will simply be 120. You see it's coming back. Plus 360k, k being an element of all integers. Yes. Huh? Yeah, you can also write this, but don't forget this part. That's that. We are in the second quadrant. Remember, we have two of them. I don't know if you're talking to yourself or you're talking to somebody next to you because you're trying to understand or you're talking about something else. And when you talk about maths, please involve me. Ne? Yes. Involve me. What were you saying? Yes. Hello? Let's have a play. Got you.
So,
Yes.
it actually needs to 60 degrees. So,
we are not done.
so
Yeah. All right, I'm gonna continue. We are not done here. Yes. Yes. Okay. Wait. If you use the 120, if you use the 120 straight, that means you'll be using the first quadrant. We are not done. I want to show you what is the catch when we are using the 120. Now, remember we said cos is negative in two quadrants. The other quadrant is the third one, right? So we also have to write the solution for the third quadrant. So for the third quadrant, let me come to this side and erase this to make space. For the third quadrant, hey, wait. Third quadrant, we define the third quadrant as 180 plus theta, but this time we're using the reference angle, right? Guys, please pay attention. Please pay attention, guys. 360k. Guys, remember we're doing this for free, ne? It's free. You must respect it or you'll start paying for it. I will only come when your parents have agreed that for any extra class. All right, never mind. We will not pay for them. It's okay. All right. This is to define our solution in the third quadrant because of that negative. But if you're going to add 180 and put 120 there, it means that you are no more in the third quadrant. And if you put 120, it means you will only have one solution, which is this solution. But you have two solutions. The other one will be x 180 plus 60 360k be an element of all integers. So your x value will simply be 240. So what do we take? What do we take from this problem? Is that when you have a negative one, please pick the one which is positive. The positive just going by this angle. Yes. Yeah. When you do this, the general solution, you must check all the quadrants. But what guides you is this line, the sign there. If you had cos of x equals to half, you will not check the second quadrant and the third quadrant. You will check the first quadrant and the fourth quadrant. So this is very important. It will guide you which quadrant are you supposed to pick. You will pick two quadrants every time. There's two solutions. Are we fine? Yes. Good. So let's fix that. We'll do more problems. I have more problems. Yes. What do I get? What do I get? The what? Speak up. That the 60. The 60 is that we use this value without its sign. We are using the second function of half without the sign. The sign will act as a guidance for us to go and pick the correct quadrant. So it means if you're looking for the reference angle, always use the positive of any number that appears there. Makes sense? If we get a cos of negative square root of 3 over 2, don't use the negative in the second function. Use the value as positive. The negative will just guide you which quadrant to actually select. Let's give another one. Let's give another example. This one has been I think the only people who got full marks from this question, there were only two. All right, let's look at the other side. The other side of general solution. Determine the general solution of cos 2x minus 3 cos of x. With this one, you see that you have a cos on the other side, you have cos of 2x. So it is easy for us to convert that double angle into a single angle. So what I will do, I'll take my periodic table and my formula sheet. I'm teaching physics and maths at the same time. So I'm going to change this into becoming a single angle of cos. So this will become, I'll pick square of x minus 1 is equals to 1 minus 3 cos of x. Please ask me a question. Why? It's in the periodic table. Formula sheet. Alright, I'm picking the one with cos because already I have a cos on the other side. When we have a general solution, it's easier if we work with cos's or sine. If you have the sine on the other side, you must have a sine on the other side. It makes life much easier. So this one is a double angle, this one is a single angle, so I can convert this into a single angle and see where it takes me. Are we okay? Grade 12? Are you fine? Yes. Yeah, I can't pick the one for sine because I have a cos already. There's 3 of them, right? There's the one with cos and sine. There's the one with with sine, the one with cos. I'll take the one with cos because it will make my life easier. I'll be dealing with cos only. Good. Now, let's transpose. I have 2 cos squared of x. Transpose this one to the other side. I'm going to have 1 minus 1 and then plus 3 cos of x equals to 0. I have transposed everybody to the other side. Makes sense? Good. And then we have a 2 cos squared of x plus 3 cos of x negative 2 equals to 0. Is that okay? And then same thing that we did previously. It's fortunate you are getting the same thing. We're going to try to factorize this and see if 2 cos of x multiplied by cos of x, because the factors of 2, they are few. So I'm going to put 2 this side so I can get 4x. And I'm going to make it positive, then minus 1. Somebody can also use the quadratic formula. Mr. Silo is in the office. Oh, okay. He's in the office. All right. Yes. I got you, yellow. Yeah. Okay. When you use the quadratic formula, you will say cos of x equals to negative b plus minus b squared minus 4ac all over 2a. And then your a is 2. Yes. Huh? You are come. All right. And then you use this as your A, use this as your B, and your C will be negative 2. You substitute this, it will give you 2 values. Ne? And then one of the values will be your cos of x will simply be 1 goes that other side, will have 1 divided by 2, or your cos of x equals to negative 2. Then this, you don't even have to go and test it now, because cos of x will never get to negative 2. Its maximum amplitude will actually be 1 and negative 1. So that means we're going to focus this side. You see now this one doesn't have a negative. So this one is fine. If it's positive, that's very good. We'll use it as it is. So we'll say, let's write it down. The cos of x equals to 1 over 2. Now, we go and find the reference angle, which is the second function of 1 over 2. And our reference angle is equals to 60 again, right? And then now we come back. We say cos here, the last part was saying cos is actually positive. Ne? Looking at the sign, your cos was actually positive. So you must pick the quadrant where cos is positive. So your quadrant is quadrant number 1, where cos is positive, and quadrant number 4. So your solution must be written for quadrant number 1 and quadrant number 4. So for quadrant number 1, your x will just be theta. So which is just the reference angle plus 360k, k being an element of all integers. This is Z, eh? Z for Zulus. So x will be 60, 360k, k is an element of all integers, and then this becomes the solution for quadrant number 1. Quadrant number 4.
Yeah.
Yes.
The 180 is the
We're in quadrant number 1.
180
Okay, I want you guys to understand why did I use 180. When we define quadrants, quadrant number 1 is defined by 30. Number 2 is 180 minus 30. Number 3, 180 plus 30. Number 4 is negative. So if your solution is in quadrant number 1, your theta becomes your reference angle. So that's why it's just reference angle plus 3, because we're in quadrant number 1. We take it as acute as it is. Are we fine? And then when we go to quadrant number 4, you have two choices. And is. Sorry? Quadrant number 1. Yeah, we're still here. You can also use 360 minus theta. But I want you to adopt this. It's very quick. Quadrant number 4, take the angle that you have and say x is equal to negative the reference angle plus 360k. K is an element of all integers. And then x will just be negative 60 plus 360k, k being an integers. I'm using a negative because I know quadrant number 4 is a negative theta. Yes. Wait. Okay. Right. Wait. Come down. All right. Guys, look. In your periodic table, we have two. There's somebody who really doesn't understand what we are doing here. In your formula sheet, we have double angles. If you look at your formula sheet, we have cos of 2x being equal to sine square of x, or it can be equal to 2 cos square of x minus 1, or it can be cos square of x minus sine square of x. You have an option to pick any of these three. But now you have a problem here. And in our problem, we don't have a sign. So it will be useless for us to go and look to take the one that has a sign. We are going to make our life difficult. So we are going to pick the one that has a cos, which is this one. So wherever I see cos 2x, I'm going to put 2 cos squared of x minus 1. So this will be 2 cos square of x minus 1 equals to 1 minus 3 cos of x. This has always been there. Are we fine? Yeah. I'm going to transpose everything that side and have a 0. I want to get a 0 on the right hand side. So I'm going to say 2 cos squared of x, transpose this to the other side, it will give me a negative 2. Are we fine? Because negative 1 minus negative 1 will be negative 2. And then we have a positive 3 cos of x being equals to 0. And then I'm going to rearrange this. I have a 2 cos square of x plus 3 cos of x minus 2 equals to 0. Are we okay? Now, in case you can't see it, somebody can say this is quadratic, but somebody can sometimes you don't see it. Ne? You can say, okay, hey, let's cos of x being equals to k. And then it means we are going to have 2 k squared plus 3k minus 2 equals to 0. Then you can factorize this to say, okay, I'm going to have 2k minus 1 and then k plus 2 equals to 0. Or use the quadratic formula. And then you have 2k minus 1 equals to 0 or k plus 2 equals to 0. So my k will be 1 over 2 or my k equals to negative 2. Don't forget, you didn't have k to start with. So it means your cos is equal to 1 over 2 or your cos of x equals to negative 2. Anything that is not between negative 1 and 1 for this cos of x, only cos of x, will be undefined. Right? So this is our solution. So we are going to focus here. That's why I rewrote it again. To say, let me write cos of x. So my cos of x is equal to 1 over 2. I'm going to find the reference angle, which will be the second function of 1 over 2. I'm not solving for x as of yet. You'll be tempted to say x equals 2, then you get 60 and you stop. But you will not get them full 7 marks. And then when you get here, your reference angle will say, okay, my value is 60. And I said to you guys, if this was negative, take it as positive. It will just be a guidance for you which quadrant are you supposed to pick. And then your reference angle now has been calculated. Now go back to a step before you look for the reference angle and look at the sign now. And we are saying cos, the value doesn't matter anymore because you have already used up the value. You look at the sign. The sign here is negative or positive? It's positive. So it means that your solution are in quadrant number 1. Y quadrant is positive in quadrant number 1. So I'm going to say x, which is this that I'm solving, is equals to the reference angle because the first quadrant is just represented by theta. So I take the reference angle, I substitute the reference angle, which is 60, then plus 360, k being an element of all integers. That's quadrant number 1. But cos is not only positive in quadrant number 1, it's also positive in quadrant number 4. So I must also go and find the solution in quadrant number 4. So the solution in quadrant number 4 is defined by a negative reference angle, which is a negative theta. The 360 is there. Because I'm using cos. So x will just be a negative 60 plus 360k, k being an element of all integers. You have found the general solution of this problem. You can use this. It's fine. Somebody can also say 360 minus the reference angle plus 360k, k being an element of all. You can use this. It's okay. Full mass. Yeah. Yeah, but you must not write both of them. Just pick one. Are we fine? If it's positive, if this one is positive like this one, you find where the cos is positive. Cos is positive in two quadrants. So general solution, you always get two solutions. You find out where is cos positive, which quadrant. Fine. Can we move? Yes. Yeah, we call that consistent accuracy. But you must not make another mistake again. Yeah, you probably get 2 marks out of 7. If you stop here, you're gonna get 2 marks. Don't plan on stopping there. No, we're done. All right. All right, there's another one. Now, look at the first problem. It's just 1 mark. Given that sine of x equals to cos of 2x, the examiner is not giving you, he has broken down the general solution for you. Show that 2 sine squared of x plus sine of x is equal to 0. So he's telling you, go and change this cos into a sine. He's giving you a clue. And he's giving you a mark for that clue. He was very, very nice. Next. Huh? You want to try? No. Okay, do it. Let me take a breath at you. You want to try it? Try it. Let me give you. I like that. I like the fact that you want to try this. It's tryable, Let's move, guys. Let's move. Time is money. Money is time. Okay. Look, would it be easy? No. I want. Will it be easy if the examiner said determine the general solution of sine x equals to 2x minus 1 without giving you the first one? Is the first one confusing you? It's a clue. He's saying change this to be this.
Yes, sir.
That's what he's saying. He's saying to you, change this to become this. So he's giving you a clue. When you have cos 2x, don't use any of the cos 2x. Use the one that has a sign. That's what he's saying. Continue that continue from the one on the right. If you are still confused, just start determining your solution. It's supposed to be. By the time you get there, by the time you land, what's that like? What's Huh? Can I give you the same thing? All right. I think we are moving in the right direction, but the confusion came with the examiner trying to help you, but he made things worse. So the first question, he's just telling you don't use anything except sine. Ne? So you had the sine of x equals to the cos 2x minus 1. So because I have a sine from those that are in the formula sheet, I'll pick the one that has sine. So I have sine of x equals to 1 minus 2 sine squared of x minus 1. Minus that is 0. 1 minus 1 is 0. So I transpose this to the other side. So I'm going to have 2 sine squared of x plus sine of x equals to 0. When it comes to the general solution, there's no need for you to go back here because already you know that you have simplified that. So you will have your sine of x factorizing 2 sine of x plus 1, which is equal to 0. And then we have the sine of x, which is equal to 0. Or 2 sine of x plus 1 equals to. Then transpose this one to the other side, you'll have 2 sine of x equals to negative 1, and then sine of x will be equal to negative 1 over 2. I'm going to come back and talk about this one. Eh? Let me focus on this. So the sine of x, which is equal to negative 1 over 2, I said if we find the reference angle, please use the one which is positive only. We'll come back for the sine. And then it gave us state. Then we come back and say the sine is negative. So where is sine negative? Quadrant? Focus. Focus. All right. And then what happened is we are picking the third one. Eh? The third one, we have x, and then it's 180 plus the reference angle plus 360k of all integers, x 180 plus 30, 360k, k being an element of all integers. So my x will actually be 210. Eh? Is it fine? Then we go to quadrant number 4. X will be a negative the reference angle, or you can use 360 plus, minus. Eh? So my x will simply be 360 negative 30 you'll get 330. Those are using 360 minus. You'll get 330. Eh? Good. Huh? Oh, the sign of x. Okay, let's look at the sign of x. Yeah, the sign of x. Once when your x equals to your reference angle equals to 0, just use the first quadrant. Because either way you get the same answer. If you take the first quadrant and the second quadrant, you get the same answer. So you just say x equals to 0 plus 360, k being an element of all integers. Huh? Yeah. Alright, I think we'll get a mark here for finding the factors. We'll get a mark this side, and then you will get a mark. This will be a mark. And then what else will be a mark here? Reference angle. No. Reference angle, we don't get a mark for it. And then we get a mark for the final answers. So this part only has 1 mark. So we have 1, 2, 3, 4, 5. Yeah, we have 2 solutions there. Right, let's focus. Normally when your things gets easy, you start making noise. No? Okay, now, different scenario. It looks the same, but different scenario. We do have your sine of 2x. Somebody will choose to expand that. You will have a cos and a sine at the same time. So what you can do on this one, you can change this sine into becoming a cos, because you know that if I were to have the cos of 90 minus 2x, I will still have a cos on both sides. Huh? When we use the reduction formula, is because we are going to now have a sine and a cos. Remember, we're trying to have the cos on the left hand side and the cos on the right hand side. When we're reducing what? Yes, that's what I'm doing. I'm changing on the left hand side. Because I have two angles, so it's easy for me to just change one angle. You can change the right hand side, it's still fine. We remember when you have sine 90 minus theta, it gave you cos theta. So if you have a cos 90 minus theta, you will have sine theta. So now I have a cos of 90 minus 2x. So I'm moving backwards. Sure. Yes. Fine. At least I can now have a cos 90 minus 2x because I see that this is going to be a huge expansion. Ne? We should have. But if it was only use the formula sheet, change the double angle, right? But with this one, I think we also got the same problem in the assignment. If you don't remember it, you have a problem. Very serious one. You cannot forget something that tortured you, ne? Can't. All right, fine. Never mind the assignment. Let's focus. I will send the assignment again on the group, ne? For practice, and also give you one question paper from Northwest to work with it. I also send them in. All right, let's focus. Now, when I have the cos and cos, you see I have a cos and angles and angles. When I look for the reference angle, the reference angle will simply be x minus theta because they are both cosines. Are we fine? I want that to be clear. Because there's no value. I have a cos this side, I have a cos this side. So if I second function the cos, if I say reference angle will be the second function of whatever is on the right, which is what? The cos of x minus theta. This will be gone. I'm second functioning myself. Get it? So if it's second function and angle, if second function and angle, it will actually give you just the angle. For example, let me do this. Because I know you have trust issues. Let's do this. I have the cos of 90 minus 2x is equals to the cos of theta. Please find the reference angle with a calculator. This one. It will be 10. Because your second function is this on the right hand side, right? No, it's the second function. So I want you to understand that as long as you have them both as cos or sine, to focus on the one on the right hand side, right? So the reference angle will just be this angle. And then please pay attention. All right. Now, with this one, remember, on the right hand side, I didn't have x. I had 90 minus x. And you see that this cos is actually positive. So what I'm going to do, I'm going to look for solution in cos, where cos is positive in the first quadrant, where I'm going to look for 90 minus 2x, because I'm solving for 90 minus 2x, not x this time. Do you see that? Do you see that? I'm solving for 90 minus 2x, not x. So I'm going to say 90 minus x is equals to, in the first quadrant, I'm going to have the reference angle plus 360, k being an element of all integers. And then I'm going to substitute to say 90 minus 2x is equals to, what is the reference angle? My reference angle was x minus 30. And then this will be, I'll transpose, I'm solving for x, all the x's to one side, all the values to one side. So I'm going to take this 90 to the other side, I'm going to take the x's to this side. So I'm going to have a negative 2x minus x is equals to negative 30 minus 90 plus 360k, k being an element of all integers. I'm solving for x. So I have negative 3 is equal to negative 120 plus 360 k being an element of all integers. Remember, everybody by negative 3, including the 360. So my x will be negative times negative is positive. 360 divided by 3 will be minus 120, k being an element of all integers. Yes. X divided by 3. When I was simplifying the x values, I took all x values to one side. I had an x minus 30, so x goes this side, I had negative 2x. So x, I have now negative 2x minus x will give me negative 3x. The 90 goes the side, so I had a negative 30, 90 goes the side, changes the sign, becomes negative 90. And then now I have negative 3x equals to negative 120 plus 360k, k being an element of all integers, then I divide by negative 3 to get rid of negative 3. And then 120, negative 120 divided by 3, negative times negative is actually positive. Positive divided by negative is actually negative, then 360k, k being an element of all integers. But we are not done because this is just quadrant number 1. Quadrant number 4, where cos is positive. So I'm now going to have 90 minus is equal to negative the reference angle plus 360 k being an element of all integers. This is where I appreciate using the negative angle, because there's no a lot of numbers to move around. Get it? Fourth angle. So I'm going to take 90 to the other side. I'm going to have 90 minus 2x. Remember, my reference angle is simply x minus 30 plus 360 k being an element of all integers. So this goes this side. So I negative 2x, x comes this side, minus x equals to yeah, it will be a plus x. Thank you. Negative x. No, it's fine. Thank you. Thank you very much. Okay, we move the sign. So I'm gonna have, let me just say, let me erase this. 90 minus 2x equals to negative x plus 30, 360, k being an element of all integers. Then let's move this to the other side, this to the other side. I'm going to have a negative 2x. This will be a plus x equals to a positive 30 minus a 90 plus 360, k being an element of all integers. So I'm going to have a negative x being equal to a negative 60 plus 360, k being an element of all integers. And I multiply by a negative, or divide by a negative. So I'm going to have x equals to 60 minus 360, k the element of all integers. And then this is our two solutions. So if you can understand this part, why we get the reference angle equal to, you can swap them, you still get the same answer.
So what we use the 90 minus 2x.
It's because this is the, remember this is the angle that we are looking for, not x. We are so, remember the other one, we had cos of x equals to 1 over 2. So the angle that we are looking for was actually x. But if you had cos of 2x equals to 1 over 2, you will still get that as 60. But when you go and solve, at the first one you will say 2x equals to then the reference angle. So the angle on the left hand side is the one that you're going to use at the later stage when you are solving for x. Yes. Yeah, because the sign of cos is positive. Yeah. It's the angle, yeah. We still have time to practice them. I've also given you, I think I've taken in all the question papers that I had, I took out all the general solution, all of them. So today we're going to do all the possible general solution that we can find in the 2018 until 2025. Yeah. Yeah. What is saying? He's saying this. Okay, and his space. He's saying, why don't I use, you can do this. And I always, to make my life easier, I always use the one on the left hand side. There. To make my life easier. You can do this. You can say, the cos of x minus 30 is equals to sine 2x. And then you can change this like we changed it that side, or you can decide to change this one and say this will remain a sine. I'm going to change this and say this is the same as sine of 90 minus x minus 30, which is equal to the sine of 2x. It's complex, but it's possible. And then when they say their reference angle, you say the reference angle is just 2x. Because the side and the side. You get it? The reference angle become, and when you go and look for the first quadrant, what are you going to do? You're going to say, you are solving for 90 minus x minus 30 is equals to, and then the reference angle plus 360k. When you transpose them and solve for x, you will still get the same values. Yes. Yeah. Now you can swap the two. From this, you can decide to say my reference angle is actually equals to 90 minus 2x. But when you solve, you're not going to use 90 minus 2x, you're going to use what? X minus 30. Can I save and go? Try this. Try this. It will tell me everything about you. This one is exactly what you got in the assignment. It's yours. It means we are fine. Can we move? Let's be fine then. When you speak, it means you're telling me, right, no, this is too easy. Try that. your only challenge is to identify them and see which is which. Are you going to use the double angles or are you going to use 90 minus? You need to pick which is which. And it will tell you, once you see x minus 8, you must know it's this one. Change it using 90 minus. Those are making noise. Yeah. That can be I get it. Put it back up they're not enough, so I focus this. Yeah, I know. Categories. I'm not right. All right, guys. I'm gonna explain this one more time. Hence, the problem is appearing twice, né? And then. Yeah, take them and sit down, man. All right. Look. I'm going to say sine of x minus 30 because it's gonna be complex for me to change that to cos. So I'm gonna simply take your cos of 90 minus 2x. Sine, eh? Yes, I'm with you now. Now, if you use, guys, sit down. I'll bring them. I'm gonna hand them out, category by category. I'm starting with my favorite children first, then. I'm joking. All right. I'm joking. Yes. All right, guys. I can't even hear the question. You're saying, ma'am? Yeah, this is, you can get away with meta for this one, but I want you to get used to using minus, né? Because we know minus in the first quadrant, everything will be positive. Because if you can say, for example, if I say sine of 90 plus 2x, for this example, it will be true. Because it will still give me a positive cos 2x, you understand? But I want you to get used to use the one in the first quadrant because you won't have to worry about the sign. Because you see, with sine it's okay, but look what happens when you have cos. The sign becomes negative. So to be on the safe space, you can always use 90 minus 2x. But mathematically speaking, using sine 90 plus 2x is also correct. Get it? All right, and then once I have this, the reference angle is simply the one on the right, the angle on the right, and say 90 minus 2x. And then when I come and solve, I take the one on the left and say where side is positive, quadrant number 1. So I'm gonna have x minus 30 is equals to the reference angle plus 360k, k being an element of all integers, and then I'm solving substitution x minus 30 equals to 90 minus 2x plus 360 k being an element of all integers, and I solve for x. I'm gonna have x plus 2x, 90 plus 30, 360 k being an element of all integers, and then my 3x will be equal to 120 plus 360 k being an element of all integers, and we divide by 3, and then my x will simply be 40 plus 120 k being an element of all integers. Then I go to quadrant number 2, and then in quadrant number 2 I will simply use x minus 30 is equal to 180 minus the reference angle plus 360k being an element of all integers. Then I simplify x minus 30, substitution 180 minus, and then my reference angle was 90, 360 k being an element of all integers. Then let's simplify x minus 30, and then this is equals to, I have 180, this will give me 90, I have a negative 2x, it will now be a positive 2x plus 360 k being an element of all integers. Now, 180 minus 90 gave me 90, and then I have negative times negative is positive, transpose to the other side. I have x minus 2x equals to 90 plus 30 plus 360 k being an element of all integers. This will be a negative x, this will be 120 plus 360 k being an element of all integers, and then I multiply by a negative 120 minus 360 k being an element of all integers, and then we are good to go. Please check that one out. It's another way they can ask you for a general solution. The 180, because it was given for west side is positive. Any questions? All right. Should I? There? 180 minus 90 is 90. Yes. Huh? Reference angle. Wait. Somebody's asking a question? Yes. Can you say? Yeah. Okay. Yeah. You can say that. You can say reference angle is x minus 30. Then when you get here, you use 90 minus 2x. You can swap this. That's what you're saying, right? Reference angle is x minus 30, but when you solve, we say 9 minus 2x. Send it there. When I was in school. Yeah, that's this. I'm coming every day. Am I gonna get paid for it? I must ask Mr. Sales. I miss my kids. I miss my kids so much. Yes. Huh? Are we gonna have second break? No. If I give you the second break, we're leaving at 4. Yeah, we just. Yeah. If it was me, we would have been in school, sleeping in school from Thursday. And it was unfortunate. It's not yet time. All right, try this one, Jerusalem. Right, let's respect time, ne? It is only 7 marks, so let's spend 7 minutes on it. Please try the level best. Try any pen that you have clues there, and then find a general solution. This is the easiest problem we have done today. Yeah, look at it right, and you see it's the easiest problem we have done today. Work, guys, work. Yeah, that's what you do. Any volunteer? Okay, and now I was making copies, so you should have just taken this. So you ate your information. Cause and effect. Consequences. Do you like it? Right, I'm going to give solution to this one. The clue is that you must get sine of x equals to -5 and sine of x equals to 3. The 3 will not have a solution, -5 will have a solution, and then you pick the quadrant. Simple as that. You just change this to a sign because your life is full of signs. Huh? We didn't get a page, yes. I still. But I'll also send a soft copy, né? Huh? With the ton. Yeah, we call it
Of course, yeah, I'm happy to see that I'm white. I must say thank you, man. Thank you.
All right. Let's refresh. This another problem. I need your attention again. Another problem here, ne? I've been standing up for exactly 6 hours. Ne? 6 hours of standing for you. My back is now. You've been sitting for 6 hours. There's no break. Break is for the people that have breaks. We are moving on. You just have to say hour. So at least I want us when you say when you get to 3, at least we have done this part. The rest you can do it for. But this one is what you actually skip. You don't even write, you skip. General solution, you skip, you're not gonna skip it anymore, right? Yes. Good. Thank you. Okay, look. This is the easiest part of trigonometry if you understand what is actually happening. Let's look at this graph. You are given a graph of f at x equals to the sine of x plus 1 is drawn. So the first question is saying write down the range of f. So range, you look at the y values. And then they're saying write down the range of f, but if you're just going to focus on the diagram here. Are we together? No matter what you know about this graph, to here. So when you measure something, you start from the lowest to the biggest. Again. So y is an element of, and then where do we start? At 0, where do we end? At 2. Simple as that. That's your range. Range, y domain. Right? That's why our x's are dom, because they are domains, the x values. Good. It's a fact, yeah. All right, and then show that. Let's look at the problem. Show that sine x plus 1 is equals to cos 2x can be written as this. He's giving you a clue again. General solution within the problem. So this problems like this must not scare you anymore. Are we together? We are going to change this into something that has a sign. Right? Great. So I'm going to change this into 1 minus 2 sine squared of x. Let's do it just to make sure that we are fine and I will not worry. I can sleep for the next coming 24 hours. We have a sine of x plus 1 is equals to 1 minus 2 sine squared of x. And then I'm going to transpose everything to the side. I have a 2 sine squared of x minus 1, right? And then plus sine of x equals to 0. So what's actually happening is I have a sine of x if I factorize 2 sine x and then plus 1. We have seen this problem before. We have seen this problem before. And then this is its general solution. That's where I got it from. I got it from this problem. Are we fine? So I'm very confident that when it comes to these problems, even if they can separate them, I have a 6 marks from my kids. When I start marking your paper 2, I'll put in total mark and say I get plus 6 because this 6 has already been counted for. Next. And then we also have proofs that you promise that you're not going to miss them. All right? And then, let's see if it continues. This, calculate, take out your calculator. Mine is saying if I press mode setup, it will say number 7 is table. You don't have a calculator? Yes, that's what I'm saying, mode setup. Some of you guys, your calculators have been pressed so long that it's there. Just buttons. And then somebody's relation says, can you bring me, I take your calculator, I brought you other gets frustrated and they are crying there because the calculator doesn't have numbers. Ne? Okay, and then put in the equation, this equation, put in your f at x. Even if it's written as g of x, your first graph will be f at x. Put this. And then start where they say you must start at negative 90. End where they say you must end at 270. Your steps, you check them from the graph. 0 to 45 is 45. Do you get those steps? And then give me the negative 90 is how much? Negative 1. Dot. Negative 45? Is how much? 0. 0. 45? 90? We get the picture now, right? 135? 0, and then 180, and then 225, and then -1. It's you drawing the curve. The curve, it must be a curve. Don't make, I know you are from Apex, but don't do top of the mountain. It must be a curve. That will be your beautiful graph, unlike mine. Now, when they ask you to draw a graph, you must know you are going to use that graph. If you get it wrong, you cannot answer the other questions. So you must make sure that you can use your calculator and then look at where our graph is starting, look where our graph is ending, and use the correct steps. It will actually give you the correct, you don't have to stress about graphing your graph. Then determine the values of x for which f at x plus 30 is equals to g of x plus 30. Now, we want, the question is saying we are looking for where the graphs are actually intersecting after you have moved the graph 30 units to the left. So look for the graph where g of x is equals to f at x. It must be visible from the diagram. Look at the points here. 0 and 1, 8. That's where the graph actually intersecting. Right? And then now, what is happening there is that because we're putting a plus 30, it means we are moving the graph 30 units. Where? So if my graphs were meeting at 0, when x equals to 0 and x equals to 180, and I move them 30 units to the left, what will be the new point be? -30. And then this one? 150. Using the graph. No need to go and substitute. It's very rare when the examiner asks you to go and find a very, very big problem when it comes to trig functions. Unless if he says go and find the general solution. That's the only biggest thing he can ask you. Find a general solution. The rest, you must interpret what is already there. Are you fine? Just fine, Rebecca? Are you fine? I'm gonna start calling you that. That's your unique name. So that's our 3 marks. And I love this. And I knew that, you see, it has been squeezed in. That question at the corner. Consider the following geometric series. Lesson. It is geometric. How do you know something is geometric? Huh? They have common ratio. So it means our R will be how much? Term 2 divided by term 1. It will be the easiest one. So our R is 2 cos 2x. Now, they're saying, remember the graph of gx, they say use the graph of g, and the graph of gx is actually the cos of 2x. Use the graph of g to determine the values of x in interval 0 and 90, for which this series will converge. So the series will converge when r is between -1 and 1. Put this thing here. We have -1, 2 cos of 2x, and 1. And then because you know g of x is just cos 2x, you divide both sides by 2. So you have a -half cos 2x and 1 over 2. I divided everybody by 2. And then if you're asking yourself, how did we get r? We have term 1, term 2 over term 1. So we said r because they told us it's geometric already. So we'll say term 2 divided by term 1, and then term 2 is equal to 2 cos of 2x over 1. That's why our r is simply 2 cos of 2x. Make sense? Make sense?
Yes.
If it doesn't make sense, it means we had a problem with geometric series. The question is saying, consider the following geometric sequence. There we go. We're going to find r, so I'm going to take the term 2 divided by term 1, 4 cos squared 2x. And then my r is equal to 2 cos 2x. And then it's going to say, use the graph of g to determine the values of x in the interval 0 to 90 for which the series will converge. For the series to convergence, my r must be between -1 and 1. So I know my r is 2 cos x. So now 2 cos of 2x, I want to get rid of this 2. Why? Because they're saying use g. And when I look at g, g is cos 2x. So I'm trying to make this to look like g. So I divide by 2. I divide by 2, the 2 is gone, the 2 is gone, and whatever I do on the left, I must do on the left and right. Right? So I now have -1 over 2 must be between the cos of 2x Yeah, no, this is g now. Yeah, after this step, you go to the graph. Like, after this step, you go to the graph. You are looking for where g is between -half and half. Look at g. G is the graph that you just drew. Half will be here. -half will be here. You are looking for g, where g is between -half and half. Let me use a different color so you can see. You are looking for your solutions. Remember, looking for the values of x. So you look at from here, if you are accurate enough, because mine is not accurate enough, so I don't know what critical value is this. Right? Just somewhere here is half. So for example, let's say half was there. I want the values of x here. Where these values exist. So I will say it will be between whatever value is here. Let's say x is equal to 135. Né? X is an element of between 135. And then it moves. After here, it breaks out. Do you see? It's above the line. Do you see? My graph of G is now above the line. Maybe probably I'm between 45 and 0, which is maybe 22.5. Ne? Here, I can be 45 plus 22.5 would be how much? 67.5. So from because it's not included, 67.5. Then I come to this one, which will be 22.5. Number 1. And then I see after here, it is on top, and it comes back here. Let's say it was also at 22.5, just for clarity's sake. $22.5, and I'm not including it because they didn't add this is not included. Do you see that? And then it will exist until it gets here. It will be probably at the same value, but the positive one. 67.5. It goes out again, comes back this side. Between 90 and 135. It will be how much? Between 90 and, let's say 22.5. And yeah, between 90 and 135. One? 112.5 or 3.5, and then it will move because it's still inside here until we get here. So it's moving in pieces, you see. And then between 180 and 135. 157.5. And then the last part is this one. How much? It's between 180 and 225. 202.5 and 270 and 225. Is that much? 247.5. Those are your 4 solutions, and the other mark you get it from simplification. That's your 5. So you are using the diagram. Ne? So your diagram must be correct. Huh? Yeah, we're using the graph of G. Ne? Yes. 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 Okay, yes. Now, look, grade 12. Now, let's say we need to pick the specific one that they want. Ne? They say it must be between 1 and 1. Between 0 and 90 degrees. That means that we're looking for between 0 and 90 degrees. How many solutions do we have then? Let me highlight it. We've written solutions there. So we're going to start here. The graph is still inside, so we're going to pick this one. From here to here. And then the other one, by the time it comes in, there's no solution. So from the 4, which one do you pick? From those 4, remember you had 22.5 and 62.75. This becomes your only solution. I gave you all the solutions that it can actually make sense to you. Then the examiner is saying specifically, we're looking for this one. But if you want to save time, you don't have to pick all of them. It's just for your understanding. If you understand what the problem is saying, it will be easy for you to solve it. Yes. And you get the right series. You will not know if you use the graph. But it's gonna take you longer though. Is it? You try it? All right. And remember, it's only equal size, so you cannot second function. It's an inequality. All right. Just focus just a bit. Just focus. I know your brain is tired, but yeah. The graph of f at x equals to cos x minus 45, g of x is negative 2 sin x are drawn below. We have f, we have g. The first question wants to say, show that the cos of x minus 45 is equals to negative 2 sin of x can also be written as the tan of 0.2617. You must show, that means you must simplify this for it to give you, let us take it one, it's 4 marks. We have 4 x minus 45 negative 2 sine of x. So I'm going to say cos of x, cos of 45. Because it's a cos, I'll use the plus. Sine of x, sine of 45 is equal to negative 2 sine of x. And then I have a cos of x, 1 over square root of 2. Sine of x, 1 over square root of 2 equals to negative 2 sine of x. I'm going to take this to the other side. I have a cos of x multiplied by 1 over square root of 2 is equal to negative 2 sine of x. Pay attention. Minus 1 over square root of 2 sine of x. Then I see that these are like terms, so I can just say negative 2 minus 1 over square root of 2 from the calculator. How much do you get? Because they are like terms, negative 2 Give me the decimal. Negative 2 comma. Negative 2 comma. 7 1. Yeah, give me as many as possible. 707-106. Let's leave it as that for now. All right? And then what we can do, we can say the cos of x, then we divide by, multiply by square root of 2, ne? We multiply by this, or we can divide by 1 over square root of 2 on both sides. Divide by 1 over square root of 2. And I want this value this side. Ne? I have a cos of x will now be negative 3, 82842. Both sides by cos of x. This will divide this, because I'm trying to get a tan. Ne? I'll be left with 1 equals to negative 3, 82842, and then this will be a tan of x, sine over cos. Ne? And then I divide both sides by that negative 3, 8242. Negative 3, 8242. And then your tan of x, negative 0,2612. No debate. Yeah. If you get it, you can easily shortcut it. Ne? But I want you guys to understand where every value is coming from. Ne? You can just use the other values from your calculator, and then you will get your 4 marks. And then after that, I can see people are tired now. When you are tired, I will not be there tomorrow. You understand? You'll be alone at home. So I want to deal with the gray areas. You'd rather be a sponge, just consume, or you'll watch the video later. But I will not, no extra class. I'll be there to answer questions when I see them, when you send them. But there's no contact tomorrow. But you still have 30 minutes. So if you can just bear with me. Once this one is sorted, I know I can go and rest. And then they now say, solve the equation for x between negative 180 and 80. Now, this is the same as them saying to you, find the general solution. Remember, this will give you this. So you can start from there, from here. You say the tan of x 0,2612, and then you find your reference angle function. Like I said to you guys, just use the positive one. Second function gives you of tan. Can depend on one person to give you guys answers. This one, second function of 0,2612. 40, 14. 14, okay, 6, 4. All right. And then they are saying we must find a solution between negative 180 and 80. That says remember this is negative 180, eh? So what you do is that you're going to pick the quadrant that you need, where tan is actually negative. Where is tan negative? Quadrant number 2. Which is equals to 180 minus 14,68 degrees, and then because it's tan, you're not going to use 360. You're going to use 180. K is an element of all integers. And then this will help you to get your answer, because your answer will be 180 minus 14,68, which is how much? (180 minus 14,68), 165,32. Now, when you are here, it's easy for you to, when you are here, it will be easy for you to find the solution from quadrant number 2, because you can play around with K. It's 6,4. Okay, good. Good. Now, when we are here, we can simply find the solution by changing the value of K. You can just put K equals to 1 here, and then it will give you 165 plus K, or you can put minus 1, it will subtract 1. So what I'm saying is that you can use this because it's only for 3 marks. So you can use this, or you can go and find the other solution, but your solution must be specific for this one. So what I will do, I will say, okay, let me put, if I put 180 here, it's going to get 180, it's going to be bigger than 180. Let me put negative 1. I'm going to have 165,32 as my first solution. And then my second solution, I'm going to put 1 or negative 1 there. I'm going to have 165,32 or 36 minus 180, because I'm going to put negative 1. And then my answer will be 165,36 minus 180. Give me a negative value. The brain is out. Minus the reference angle, but I want us to understand what we are doing. Ne? So it will also help you if the examiner gives you this and say find the general solution without even having to. You see what the examiner is doing. He separated the general solution into 2 steps. So the first part and the second part for 3 marks. So you can minus 180, it gives you 14, right? Negative 14,64. Or you can use the 4th quadrant to say negative reference angle, and it will still give you the solution. like a smooth. Yes, yes.
Sir, it's cut.
Let's do some few problems and we go. I must send video. I'm not recording. No recording will be done for me until term 3. I'm done with recording. Alright. And then I'm gonna give you this one. Same problem. But they're asking you, I want us to talk about, because you're going to get something like this on Monday. You start fighting with me. We didn't do that one. We didn't see that one. And now you want to relax. But there's no time for relaxing. Alright? Write down the coordinate of t. What's happening at t? What's happening at t? Your f at x equals to 0. Right? So it means that y is 0. What will be x? Remember f at x is equals to cos of x minus 45, né? What will be the value of x? This is square root of 2 over 2. The value of x must be an angle. Look, remember y is equal to 0, so your cos of x minus 45 is equal to 0. Your second function, then you get 90. So your cos of x, second function of 0, is equal to x minus 45. This is 90. We have 90 equals to x minus 45. You transpose that to the other side, is 90 plus 45. So your x equals to 135, right? So the point here, your x value is 135 degrees. And when you know the Mara graph, I'm not gonna end. I want to finish here. Look, when you know the Mara graph of cos, it starts at 0, 90, 180, 270, and 360. So, when you look at 180 is here, and then this will be 0, 90, 180, 270, 360. So this will be a 270. Not here, ne? Oh, my brain is shutting down, but it's fine. So what is gonna be the plan if I go? If we go? That's what I'm. We have a solution to go. What are we gonna do with the rest? All right. Okay, let me. Or should I give you a break and we come back and we leave at 5? let's do this. Let me show you. I'm gonna send this to all of you. Ne? I hope the office so I can make copies for those who don't have copies. But I'll send a soft copy. And then this is what we didn't do. Look. But mark the graph. Okay. You can pick up the cake. Yeah. Unless we say let's take 5 minutes break. Yeah, let's get a 5 minutes break. We'll come back to Konatu, and then we have 15 minutes. That's 15 minutes is very important because we're not so clear. That's 5 minutes. You're not focused. You're not getting what I'm doing. 5 minutes, guys. Get some oxygen in that break.
This one, first thing first, we say this is a geometric series. What does geometric series tell us? It tells us that R is equal to T2 over T1. T2 is this. See? T1 is 1. So this divided by 1 is just R is equal to 2. And then they could say use the graph of f of g to determine the values of x in the interval between 0 and 94, which the series will converge. Convergence. Right? This is R. I put R here. Sharp. Now when I look at g of x that was given to me as cos 2x. So I want this to look at least like this. So the only problem is this 2. So I remove that 2. But if I remove it, I must remove it everywhere. So my g must be between -5. So in actual sense, this is g of x. So g of x is between -half and half. I come to the graph. I already had a graph. So I'm going to look on the graph. Just focusing between 0 and 90. Where is the graph between -half and half? And I mark it here. If it's half here. And half and -half. I mark it. Where the graph exists, I write from where to where. So you must have your graph. Next, practice it. Call them, Chile. Yeah. Hey, get off.
You know what I mean? They just close. They know what to know. You must have thrown
I'm going to call those people. All right, great stuff. Remember, we got two values. I think it was 165. Am I having your attention? The more time you waste, the later we leave. All right. Okay. We found the value of t. And then the next question is say write down the for which f at x is greater or equals to g of x. So this simply means simple things.
if you are given that, it means the one which is bigger must be on top. The one which is smaller must be at the bottom. So you go to your graph and look for that. Already you have this interval from the general solution that we have 14,65 or 14,36, the one that we got, ne? And then we also have another intersection at 165,36. So it's saying where is f of x greater than or equal to g of x? And when you look at this, f of x is on top here. Do you see it? And then g of x is at the bottom, which is where we want. And then when you come this side, your f of x is at the bottom and your g of x is on top. So our answer will be x is an element of from, including 14,65 until 165,36. Huh? They're included because now they're saying you must also include where they're equal. So they will be included. So if the inequality is given as included, your answer must also be included, unless if that point is an asymptote. Yes. Is that? Remember the previous problem. Is the previous we are continuing from the previous year. It's the same problem. It continues. Remember, it says your tan of x equals to negative 0.26. Find the solution between negative 180 and we find two values. The other one was 14,65 and the other one was, it was actually negative 14,65 and the other one was 165. So you're gonna use that to actually write your answers. And then let's look at the third question. Remember, all the problems that are placed here, they are placed on purpose to teach you something that I think that you don't know. Ne? Write down the interval for which both f and g are strictly increasing, both of them increasing. How do you know that a graph is increasing? Okay. Now, let me say decreasing as negative, increasing as positive. Ne? So this will be decreasing, ne? Until the turning point, and then to start increasing. So this graph is increasing here. Right? And then the f, the marking are for increasing and decreasing, ne? Not for the value of y. Here is 0, ne? And the turning point is 0. But we'll talk about that more. So they're saying for which values of is the two graphs strictly increasing, where both of them are increasing. We see that from negative 180 until the turning point, the two graphs, this one is decreasing until here, and then this one is increasing. So you might find that from just this point, just this part, from this turning point, this part, that's where your graphs are both increasing. Do you see that? Just that part. Let's look at other parts where the graph is, here the graph is increasing, and then decreasing. This one is decreasing. Then when you get here, there's no other point. So the point is just here.
between the two turning points of the graphs on the left hand side. So we have the equation, and then what is this point? Let's start there. What is that point in terms of x values? We have this one, we know this one will be -2 because the amplitude here +2 and -2, and then this one will be 1, -1, and yeah, it will be -1. So I'm looking for 2 points. I'm looking for 2 points where the other one is -1. The one of G is equals to -1. Remember, it's a graph of cos. Ne? So we want to find out what will be this point. So we can quickly go to the calculator and say, okay, I have a cos of x minus 45 equals to -1. Ne? Yeah. And then x minus 45 equals to the second function of -1. It gives us how much? 180.
The second function of
It's 180, ne? -180, 180. Did okay. 80. Your x is 225. Good. And then let's take a look at this one because we're looking for a negative value this side. Ne? We're looking for a negative value that side. It's fine because it's 360. We can just subtract 360 because the period of and sine is just 360. We'll come and fix this one. Let's look for your sine, negative sine of 2 of x is equal to -2. Then we are going to say the sine of x equals to -1, and then x will be the second function of -1. We're going to get this point, these 2 points. What will be our value here? -90. So we have for that one, this part will be our -90. Now from this, can we subtract 360 and see how much we get? -135. So it means that our graph is strictly increasing when x is an element of from negative, not do that with the turning point 135 until -90. So that's where your graph is increasing. So with this one, you need to know the turning point, and you see that when you get to 10.3, the examiner will start asking you more of this question. I saw some on the question paper, he asked you something like this, né? Yeah. He asked you something like this. Why is it? For this one, in case if we have this, oh, okay.
is going to be negative 135, not included. If it's in between, they all face to the left. If it's between two values, if it's within, they always face the left. The only one that faces to the right, inequality, is greater than, only bigger than. The rest they face that side. Are we fine? Good. I know some of you would like to go home and do nothing. Some of you, yeah. All right. Now I'm going to be on a lighter note, so that at least you have an idea what's happening. Look at the graph of H. It's obtained when the graph of F is shifted 45 to the right. Write down the equation of H in its simplest format. The graph of H of X is the same as when we shift the graph of F at X 45 units to the right. Remember, when you shift something to the right, you subtract. So it means that your h of x will be the same as the cos of x minus 45 minus 45, because it already had a 45. So this will be h of x being equals to the cos of x minus 90. And now I'll take out a common factor of negative, so I have your h of x being equals to the cos of negative x, be able to comprehend without adding 360. So we take this as a negative angle where cos is in the fourth quadrant, cos will be positive. So my h of x will simply be the cos of 90 minus x, which is your h of x is the same as sine of x in a simplified format. Yeah, and then we can now remember you have 3 o'clock on Mondays. All right. I'm gonna send the video to 3 o'clock. Alright guys, so it's fine. If you have any questions or if you need, I'm gonna send this as soon as I get home. Those who have papers are very fortunate. I also have one set here, but you don't really need the papers. I'll send a soft copy. Practice. We have 4 topics. There's also, don't forget analytical, it's easy to forget it. They are question papers that I've sent to you guys. Please also use them. Huh?